On October 19, 2017, astronomers in Hawaii detected a faint object moving through space. When they calculated its path, they made an extraordinary discovery. This object came from outside our solar system. It was the first interstellar visitor ever detected passing through our cosmic neighborhood. They named it ʻOumuamua. By the time of discovery, ʻOumuamua had already passed closest to the sun and was heading back into deep space. Scientists had only weeks to study it before it became too faint to observe. Tracking the object revealed unusual characteristics. Its brightness changed dramatically every 8.67 hours, indicating either an extremely elongated shape like a cigar stretched 10 times longer than it is wide, or a flat disc-like form. No telescope could see its actual shape, only a point of light. Analysis suggested it was between 100 and 400 meters long, with a slightly reddish surface color similar to icy bodies in our outer solar system. Then came the mystery. Precise measurements showed Oumuamua was accelerating away from the sun in a way gravity alone couldn't explain. This resembles cometary behavior. When comets heat up, ice evaporates and releases gas that pushes them forward, creating visible tails. But Oumuamua showed no tails, no gas emission, nothing visible at all, despite passing closer to the sun than Mercury. By late 2018, Oumuamua became undetectable, traveling toward the constellation Pegasus. No spacecraft could catch it. The brief observation from October to December 2017 are all we have. Oumuamua remains the first confirmed visitor from another star system and the only interstellar object observed with unexplained acceleration. On August 30, 2019, amateur astronomer Gennady Borisov discovered a moving object using his homemade telescope in Crimea. Follow-up observations confirmed it from outside our solar system. This was the second interstellar object ever detected. It received the designation 2I Borisov. Unlike Oumuamua, which showed no visible activity, Borisov displayed a clear cloud of gas and dust from discovery. This identified it as an active comet, allowing scientists to study it using standard techniques developed for solar comets. Multiple telescopes, including Hubble, captured images showing material streaming from the nucleus. Chemical analysis detected water vapor, carbon monoxide, hydrogen cyanide, and other molecules in the surrounding cloud. The overall composition resembled comets from our own solar system. However, one measurement stood out. The ratio of carbon monoxide to water was extremely high, with carbon monoxide at least 50% more abundant than water. This ratio exceeds almost every comet ever observed. The elevated carbon monoxide indicates Borisov formed in an extremely cold region of its home star system, far beyond where water freezes. Measuring the nucleus size provided difficult due to its surrounding gas and dust. Early estimates ranged from 1.4 to 16 kilometers across. Refined Hubble observation narrowed this to probably between zero point 0.4 and 1 kilometer in diameter. Determining rotation period was equally challenging, with studies reporting conflicting results ranging from 4.3 hours to over 13 days. The comet reached its closest point to the Sun on December 8, 2019, at approximately twice Earth's distance from the Sun. As it approached, activity increased. On December 28, it passed closest to Earth at 1.9 times the Earth-Sun distance. In February and March 2020, the comet experienced violent outbursts. Hubble images from March 30th showed Borisov had ejected a large fragment, indicating the nucleus had broken apart. This fragmentation is consistent with weakly bound icy comets that crack under heat stress. Trajectory analysis showed Borisov entered the solar system from the direction of Cassiopeia and exited towards the southern constellation Telescopium. The comet is now beyond detection range, traveling permanently into interstellar space. On July 1st, 2025, a robotic Cerbero telescope in Chile detected a faint moving object. Within 24 hours, observation confirmed it came from outside our solar system. This was the third interstellar object ever detected, designated 3I Atlas. The object's trajectory showed the highest measured eccentricity of any interstellar visitor, 6.139. This exceeds Oumuamua's 1.2 and Borisov's 3.4. The comet was traveling at approximately 61 km per second relative to the Sun, or over 200,000 km per hour. Earlier images from other telescopes, dating back to late May, confirmed the hyperbolic path. Unlike Oumuamua, which showed no activity, 3 Atlas displayed a visible cloud of gas and dust. Observation confirmed cometary features within days of discovery. Hubble telescope measurement determined the nucleus is likely under 1 kilometer in diameter, similar to Borisov, with an irregular shape rotating approximately every 16 to 17 hours. Chemical analysis revealed striking differences from typical solar system comets. The surrounding cloud is dominated by carbon dioxide, with carbon dioxide to water ratio of approximately 8 to 1. This is one of the highest ratios ever observed in any comet. The composition also includes water vapor, carbon monoxide, and various carbon compounds. Cyanide gas and atomic nickel vapor is also there. Comet reached its closest point to the Sun on October 29, 2025, at a distance between the orbit of Earth and Mars. It passed close to Mars on October 3rd, Venus on November 3rd, and will pass Earth on December 19th at 1.8 times the Earth's sun distance. The closest approach to Jupiter occurs on March 16, 2026. Trajectory analysis shows three atlas entered from the direction of Sagittarius near the galactic center. After perihelion, it is now exiting towards the constellation Telescopium and will not return. Analysis of the comet's galactic motion suggests it may be between 7.6 and 14 billion years old, possibly originating from the older stellar populations in the Milky Way.